Let's have a look at how to solve equations graphically. Now, before you start this note, make sure that you have grids or graph paper, and you can get those from your teacher. So we have two equations here, and I'd like you to set up your grid, and then I'd like you to jot all this stuff down beside it so that it's nice and organized. We've got two equations. Y equals 2x minus 8 and y plus x equals 7. Now also, it's good to label each equation with a number 1 and number 2 equation and put them in a circle, because if you don't put them in a circle you might think that it's 1y and 2y, so you always want to do that. And I've color coded mine just to make them clear. So equation 1 is as follows and equation 2 is as follows. Let's look at what it means to solve it graphically, to solve this set of equations graphically. Let's take equation 1 and let's identify the y-intercept. The y-intercept is negative 8, so that's from the y equals mx plus b part of the equation. It could be plus or minus b. But the b is negative 8, so that's our y-intercept. Our slope from equation 1 is actually 2 over 1. Any whole number can be written over 1 and it doesn't change. Notice that this would still be 2. But we need a rise over run for our slope, so we always make sure that we have a number on top and a number on bottom. Now let's look at where that is on our graph. How would we draw that? Let's go to our y-intercept of negative 8. And then to get our second point, in order to draw our line, we used our slope, which was our direction. It tells us where to go from the y-intercept. So we always start at the y-intercept. We don't start at 0 again. We start at our y-intercept, and that slope says rise 2 and run 1. So rise over run. Rise 2, run 1. So we went rise 2, which is up 2, and right 1. Okay? And then we put a second dot there. And then we'll draw our line through. So that was equation 1. And I want to remind you, how did we know to rise and go right instead of, or how come it's not go down and to the left or up and to the left? So let's remind ourselves about this coordinate grid and the axes. So remember that going in an upward direction is positive, going downwards is negative, and then going to the left is negative and going to the right is positive. So since this is a positive 2 and a positive 1, it means up 2 and right 1. Let's look at equation 2. We have to rearrange it, and I want you to notice that it initially was given as y plus x equals 7, and now it says y equals negative x plus 7. So remember, we did change side, change sign. So the positive x came over to the right-hand side and we made it negative. And that's necessary so it's in y equals mx plus b format so that we can sketch it. So let's identify our two key features. Our y-intercept is 7 and our slope. There's actually a negative 1 in front of this, but we don't write it because it looks weird. So it's negative 1 over 1. Okay, and so what we're going to do to draw this is we're going to go to 7 on the y-axis and we're going to go down 1 and right 1. Okay, so there's our 7 on the y-axis, and we're going to go down 1 and right 1 to get to our next point. And we're going to draw a line through there. And what we're also going to notice then is where do those lines intersect? And that's the solve part. Solving means where do they intersect. So notice that it's at 5, 2. It's written as a coordinate point. That means our x direction and then our y direction. So this point is identified as, and remember that we read it in the following manner. It's 5 along the x-axis and it's up 2 along the y-axis. So that point is identified as 5, 2. Okay? Now, if we wanted to check, and this is something you can just do on your own, the x is 5. What does this point mean? And let's see what we solved so it makes sense. The x is 5, and that means that if I put x in either of equation 1 or 2 as a 5, okay, and then I'm using this rearranged equation here for the second one, but if I put 5 in here and 5 in here, that's where my x's are, I should get 2 as an answer for my y's. Okay, so go ahead and check that. Put the 5 here and put a 5 here and see if this y value becomes a 2. Can you get 2 out of that? Okay? And that means that when you make x a 5 in both equations, you get the same answer of 2. And that makes sense because this is the same point on both lines. Okay, let's look at our next equation or a set of equations. Another two that may or may not require some rearranging. So we've got equation 1, y equals negative 2x plus 6, and equation 2, y equals 2 plus 2x. So with equation 1, let's identify the y-intercept as 6, and the slope is negative 2 over 1. So that's nice and easy. And I'll just go a little quicker now because we know what we're doing, hopefully. So we've got our y-intercept there, and then we went down 2 and right 1 to get to our next point, and that looks a little bit off, but make sure that you draw it clearly. Down 2 and right 1. Now, how do I know with this one? I wrote the negative in front. So, but remember from here, it's a negative 2. But it really doesn't matter where you put it. You can put it on the top or the bottom, and you'll end up with the same line. So you can test that out and see if it works. So here's equation 1. So we went down to right 1. And draw a line. We've got line 1, which represents equation 1. Let's look at equation 2. With this one, we want to rearrange it again. Just change these two around. But notice that none of the signs changed because we didn't cross over the equal sign. We're still on the same side. We just changed the order. So with this one, our y-intercept is 2 and our slope is 2 over 1. So let's see where that is on our graph. We've got our y-intercept coming up there, and we went up to right 1, and there's equation 2 or line 2. And we also then notice that our point of intersection is right here, and hopefully on your grid it's a little bit more accurate than this, but it's at the coordinate point of 1, 4. Okay? And again, you can do a check, take both of the equations, plug in 1 for x, and see if you can get 4 for the y value. Okay, let's have a look at another one, just to make sure we're clear. Let's take equation 1. This one is a little bit harder because we have to do some rearranging. So notice equation 1, x plus 3y equals 9. Let's look at how we rearranged it. First of all, we want it in y equals mx plus b. So the 3y is okay where it is. We just took the x and moved it over to the right-hand side. It became negative x. So that's step 1. We can't have 3y. So what do? We divide every term by 3. So this is divided by 3, this is divided by 3, and this is divided by 3. And notice that we get negative 1 over 3, because remember I said there's an implied 1 there. So 1/3 plus 9 divided by 3 is 3. So now we've got a nice equation. We can go ahead and identify clearly the y-intercept from that and the slope. And let's go ahead and draw that. So our y-intercept is at 3 there, and we're going to go down 1, right 3 for our second point, and then we're going to draw a line through there. And then we're going to take equation 2, and we're going to rearrange that. So we have negative y. Our first step was to take this x and move it to the right-hand side, make it negative. And then we have the same problem. We have a negative y. We can't have that. So we're going to divide everything by negative 1, or it could also be called multiplying the whole equation by negative, which means all the signs would be opposite. So this becomes positive, this becomes positive, and this becomes positive because they were all negative. So the y-intercept's 3 from there. Okay, we're looking at this equation. And our slope is 1 over 1. So we're going to go to 3, and then we're going to go up 1, right 1. Okay, and we already had a dot at 3 from the other line. That's fine. We're just going to go up 1 and right 1 from there. and we're going to draw a line. And now we can read that our point of intersection is, and be careful to identify this point here, this is called 0, 3, because we don't go left or right, but we do then go up 3. Okay, so write your final solution like this, and if you needed to or wanted to, you could verify by plugging 0 into the equations here and see if you can get this 3. If you can get that, you know that your answer is correct. Let's go to our last example because this is something a little bit different. I want to just show you a different method here. So the previous 3 examples we did by using the slope y-intercept method. This one's called the x and y-intercept method. And sometimes this is just easier to use depending on what we're given, or you may just be asked to show that you know it. So let's have a look at our equation 1 and 2. Let's take equation 1. We're going to do something different. This time we're not going to rearrange it. What we're going to do is, first of all, we're going to find the x-intercept, and then we're going to find the y-intercept. That's why it's called x and y-intercept method. To find the x-intercept, you make the opposite a 0. So you make the y a 0. And to find the y-intercept, you make the opposite a 0, which means you make the x a 0. So notice I've taken equation 1, I made the y a 0. Okay, so now it's going to go away. So 3 times 0 is 0. That's going to go away. And we're going to be left with x equals 9. So now I know the x-intercept's 9. I want to find the y-intercept also because I need a second point to draw a line. I'm going to make the x a 0 this time, same equation, so equation 1, make the x a 0, and then that goes away and I'm left with 3y equals 9. If I solve for y, the 3 will swing underneath, swing underneath. I'll be left with 9 divided by 3, which is 3. So my y-intercept is 3. Okay, so remember that the method is whichever intercept you're finding, make the opposite a 0. So let's go ahead and draw that on our grid. Our x-intercept and our y-intercept was 3. So here's our y-intercept. It's on the y-axis. That was 3. And on the x-axis, our intercept was 9. Okay, don't draw them opposite because then that wouldn't be correct. Draw a line through there and we're done that. Let's do the same thing with equation 2, our x-intercept. Take the equation as is, make the y a 0. That will go away. We're left with x equals -3, so that's our x-intercept. For the y-intercept, make x a 0 from this equation. Okay, plug in the x is 0, and then in order to solve this, I would leave the y on this side and just think of moving the -3. That would go to the other side and become a +3, so y would actually equal 3. When you write it, you can write it like this, y-intercept is 3. Okay, let's draw those two things. So on the x-axis, our x-intercept's -3 over here. And our other point was already there, our y-intercept of 3, and we'll line through there. Notice that I've also color-coded these differently so that they match and match the equations, and then they're nice and easy to identify. And our point of intersection looks like it's 0, 3. Okay. So if you want to check it, also, again, you can plug in your 0 for x's and then get your 3 as your y value. So that's the same thing as the last example, only it's doing the problem using a different method. So just make sure that you are aware of both and that you are able to do both methods.